So you'll remember that when we talked about Hubble's law, we used a couple analogies. One was a skateboarder riding a skateboard, and the other was a balloon being blown up. And the way we talked about these things was we looked at the speed that they were moving with and how far they were, and we kind of created a graph, which is like what Hubble did, which was the speed of the object versus its distance. Now, another way of looking at this motion, besides speed and distance, would be distance and time. So this guy on the skateboard's moving at a constant speed, we said before. The balloon's being blown up at a constant speed, and so it's constantly moving to a new place or getting bigger or having a bigger distance. So when we talk about the universe, we saw with Hubble's law that galaxies kind of have this linear relationship between how fast they're moving away and how far away they are. That also implies then, that essentially implies a constant speed. And so what we could do is we could say, here's like the size of the universe, or the size of the balloon, or the distance the skateboarder has gone, and here's time. Okay, and so here we are at this point in time, and we could say that our universe is like this size right here. Boom. Okay, we can measure the size of our observable universe. All right, we measure the distance to the most distant galaxies. And we talked before about how, in principle, then, we could kind of look backwards and say, well, over time, the universe must have sort of been smaller, right? Until we get back to this sort of event back here, the Big Bang, where it had a size of 0, and that's where sort of time began, quite literally. The next question we can ask, though, is, well, what's going to happen going forward, right? I mean, is the universe going to keep getting bigger? Is it going to eventually kind of reach some maximum size? And here's what's really interesting is, I'd say up until the 1970s, there were sort of three possibilities that astronomers described. I'm going to draw this graph a little bigger. Here's time again, and here's size. So one possibility, and I should mention, right, the universe, we know it's a certain size right now. But the question is, perhaps the universe hasn't always been expanding at a constant rate. I mean, perhaps it was going faster at times in the past. Another factor here that might be impacting that is the universe is full of stuff, right? And all that stuff has gravity, which is attracting to it. And so it's kind of like this balloon, right? Like there's a force on the balloon, everything's pulling it backwards. The rubber gets sort of like tighter and tighter, and it pulls harder and harder. The same thing happens in the universe, where we have gravity pulling inward, fighting against this expansion. And so perhaps the universe is slowing down in its expansion, right? Maybe it's not a perfectly constant speed. So here were sort of the three possibilities that astronomers kind of predicted back in the day. All right, again, this is like 40, 50 years ago. All right, one possibility is that, yeah, you know what? It's always been a constant speed, and it will always stay a constant speed. All right, the gravity in the universe isn't enough to slow it down. So the universe will just keep forever getting slightly bigger and slightly bigger on its way. Right? Another possibility was, though, people are like, hey, no, not likely. There's a lot of gravity in our universe, so it must be that it's slowing down. So perhaps at some point in the past, the universe was expanding faster, and then it's slowing down, and it's just going to kind of keep slowing down and reach some, like, maximum size. Right? And some people said, no, hey, man, there's so much stuff in the universe that it's expanding now, but it's actually going to like slow down and turn around because the gravity's so strong, and the universe is going to start collapsing again, and maybe have some kind of like big crunch, they call it, kind of like the Big Bang, but in reverse, in like 100 billion years or something like that. So these were sort of the three possibilities that people thought might happen. The universe might just keep expanding constant forever, might slow down, might actually turn around and contract. Well, not until like the 80s, 90s, were astronomers actually able to measure how the expansion of the universe has changed over time. By looking at really distant supernovas, they could actually measure how the universe was expanding in the past. And what they found was very surprising. What they found, let me find the right color. Let's see, let's do this in pink, because pink is surprising. Okay, so what they found is that the universe was going, its speed has changed over time, and that actually what's happening right now is there was a period where it slowed down, but right now we're in a period where it's actually speeding up and accelerating. And so it appears to be the case that our universe is accelerating in its expansion. That is, even though there's gravity pulling inward, something else, we don't know what that something else is pushing it outward, causing it to expand faster and faster all the time. So not only do we live in an expanding universe, we live in an accelerating universe. And this is a real mystery. Okay, so we learned about dark matter. Astronomers don't know what causes this accelerated expansion, and so they give it a name called dark energy, because they don't know what it is that would cause that acceleration to the expansion. Okay, so this is cool. This is all related to Hubble's constant. It tells us about the age of the universe, right? But Hubble's constant is also ultimately a measure of the speed at which the universe is expanding. And what we're seeing is that number may not have always been the same throughout the history of the universe. All right, pretty cool.